a circuit diagram, please get it from your friends, or else you have the record in your hand. Am I correct? In that record, we may have some other regulator IC. In 7805 you may have it. But we are going to do with the adjustable voltage regulator. So please get the circuit diagram from the theory class notebook and start drawing. Okay. Yes. The recording started. Shall we start the class? Yes. Since it is a long gap, let me start with the initial slides itself. Let me rush up the things what we have learned it in the last classes and all. Can you anyone tell me up to which we have covered? Can anyone tell me up to which we have covered? Is it we covered up to the operating point or stability factor? Hello? Where we stopped our discussion, sir? Hello? Operating point or stability factor?
Thermal runaway, sir.
Thermal runaway. Okay, it falls in which category? Operating point or stability factor? So up to here we finished.
Operating.
Very good, very good. Operating point. So you very well know what is the need of biasing and what is the DC load line and what is the Q point. What is the abbreviation for Q? Can anyone tell me what is the abbreviation for Q? Please observe, please check your class note and tell me what is the abbreviation for Q, please. Hello? What is the abbreviation for Q? Very good, very good, very good. Very good. So we will start with the today's new thing is as a stability factor. Before that, let me show the content what we have saw already. Since it is a huge gap, first one is the what is biasing, then why we need a biasing, then DC load line. DC load line we will draw it in output characteristics or input characteristics line. DC load line எதுல draw பண்ணுவோம் outputலயா inputலயா? Output, very good, very good. Then you will find 2 points, saturation point and cutoff point. Then procedure to draw the DC load line we saw in the emitter configuration, common emitter configuration. Then quotient point or the operating point we'll learn. It's very simple. Your output characteristics and the DC load line. If you draw in the same plane, you will get a meeting point. That point is called what? Your operating point. Then what are the factors affecting the stability factor we have saw in the last class? Beta, BEB and ICBO, and also in which degree it impacts also we have saw. So all the parameters will vary due to the change in temperature. Okay. Then thermal runaway, very good. You remember this concept, what is thermal runaway? If thermal runaway increases, what will happen to your component or the device? What will the consequence of this thermal runaway effect? Hello? If it increases beyond some limit, what will happen? Which junction will get overheat?
Collector base.
Collector base, very good. Collector base junction will get overheat. That will damage your transistor. Okay. Then and also I shown this last slide to read something in this. Am I correct? Okay. What is the today's date? What is the today's date? What is the today's date?
May, sir.
3rd May. Okay, 3rd May. Please put a today's date. Please put a today's date. 3rd 5/2020. So this is a new thing we are going to start discussing today. By definition, can anyone tell me what you have understood from these two lines? Quickly. Stability factor means what? Please read it once and tell by your own words. stability factor. Yes, rate of change of two current components. Am I correct? What are all those current components? What are all those current components?
Collector current and reverse saturation current.
Very good. Collector current and reverse saturation current. By keeping the current gain and VBE, that is base emitter voltage, constant. How we will write it in mathematically? How we will write it in mathematically? This is the form. This is the form. We are going to write it in a mathematical way. Okay. So small change in the collector current to the small change in the reverse saturation current, keeping your current gain and this voltage as a constant. Okay. So if this is the formula or the definition, then how we will calculate the stability factor for our circuit? So we need to find these two parameters. If you take a ratio, you can find the stability factor. Am I correct? So now we will see. We will take the collector current equation then we will differentiate with respect to IC. Okay, ba? So collector current equation, which one is the collector current equation? This is the collector current equation we discussed in the previous slides. Okay, can you make an attempt? To differentiate this equation, please? Differentiate panna enna varum left hand side la? If you differentiate IC, hello, in the equation you need to differentiate. Shall we differentiate this one? Yes, sir. Yes. Since IC, if I differentiate with respect to same IC, what will I will get? 1. Then we will differentiate these two things. If you differentiate these two things, the beta is the constant one. Let me take it as a left hand side. The only this component depends on IC value, so I'm going to differentiate this one. Then here also the beta plus 1 is the constant, therefore I'm going to differentiate only this. Now do remember one thing, and mathematically we studied as a dependent values, dependent parameter. So these two are depends on your collector current. Okay, ma'am. So either dependency I am going to differentiate these things. Okay. Then if I rearrange those equations, if I rearrange this equation, I will get at last the stability factor S is equal to 1 plus beta divided by 1 minus beta times of change in base current by change in collector current. Is it correct, sir? Is it clear? Is it clear? Hello? Hello. Yes, please note down this.
Yes, sir.
Any doubt in this derivation, how we arrived this? How they substituted this value? Can anyone tell me? How they simply substituted S over here?
Del IC
Any
by
idea?
del ICO 1 by S substitute பண்ணிருக்கோம் sir.
It's given in the very first step over here. Please check it over here. So if you take this reciprocal, am I correct? You will get what? Yes. So the same yes they have put it here. And then if you take the S one side and the remaining terms at the other side, you will get the formula for the stability factor. Okay. So if the value of the stability factor S is large, then the circuit stability will be poor. If it is unity, stability factor will be good. Please note down these keywords. If stability factor is large, then stability of the circuit is poor. If it is unity, what is meaning by unity? S is equal to S is equal to
1.
1. S is equal to 1. If it is S is equal to 1, the circuit stability will be good. Okay? Okay? Yes. So do remember this 2 points regarding to your stability factor, and also you must remember these two results. This is the by definition, this is the thing you need to remember, and this is the end result you should remember. For which configuration it is? Can anyone tell me? This for common base or common emitter or common collector?
Common emitter.
Common
We are
emitter, sir.
discussing only the common emitter. How you will find this is related to common emitter? Any idea from your side?
Beta, sir.
Beta, very good. Beta. Beta is the current gain of the common emitter configuration. Okay. So if you refer the test book, there you will find for the remaining two things also they gave the derivations. If you wish, you can go through that also. Okay. But in our scope, that we limited with the common emitter configuration. Okay. Have you note down these two things? And
Yes, sir.
also this keyword, it's very important. Don't sit and sleep there. My humble request, if anyone still you are in the bed, please get down, sit it in the proper place, take down our electronic devices and circuits note, have a cup of water nearby to you, and listen the class. And also see, I am not wearing anything as a headphone in my ear. Am I correct? Ada wear பண்ணிருக்கேனா? Ada wear பண்ணிருக்கேனா கண்ணா?
No, No, sir. sir.
No. So I won't get any hurt. Okay. So how I am listening the sound? How I am listening the sound? I am having some speakers. Do practice the same. ஒரு சின்ன ஸ்பீக்கர் வாங்கிக்கோ, ரொம்ப நாளைக்கு இந்த காதுல ஹெட்ஃபோன் போட்டே இருந்தேன்னா see if you are keeping earphone ரெண்டு காதுலையும் போட்டு வச்ச அப்படின்னா it won't allow the fresh air into the eardrum. So ஒரு வார்மா இருந்துச்சு அப்படின்னா the bacteria will grow in an enormous way. So ரொம்ப அதிகமான நேரம் if you are using headphone, bacteria ரொம்ப grow ஆயிரும். நிறைய பாக்டீரியா க்ரோ ஆச்சுன்னா அப்புறம் நம்ம யாரை போய் பார்க்க வேண்டி வரும்? யாரை போய் பார்க்க வேண்டி வரும்? எந்த டாக்டரை பார்க்கணும் மேடம்? இஎன்டி. ஈய பார்க்கணுமா, என்ன பார்க்கணுமா, டிய பார்க்கணுமா? இஎன்டி கரெக்டா சார்? இஎன்டி யாரை பார்க்கணும்? ஈயா என்ன டியா? ஈய போய் பார்க்குற மாதிரி இருக்கும். ஓகேவா? ஸோ இடிசி படிச்சுட்டு போய் ஈய பார்க்க ஆரம்பிக்க கூடாது. டெக்னாலஜிக்கலா லேர்னிங் மெனி திங்ஸ். ஸோ டெக்னாலஜியா நீ எப்படி ஒன்றை காப்பாத்திக்கிறதுன்றதை யூ நீட் டு லேர்ன். ஓகேவா? எஸ். நவ் methods to bias the BJT. Next title. Please take down this. Methods to bias BJT. What are all the methods we shown in the initial classes? Can anyone recollect and tell me? Is it we have seen different types over there, or simply we told only we are having the types? I think we told only the types, not an elaborated titles. Am I correct, sir? Or else do you know anything related to this topic by your own, sir? Yes or no? Okay, I hope you not studied this one. Have you studied CBSE people? Have you studied this biasing? Siddheswaran?
No, sir.
No. Okay. Yes. Now we will see the types. Okay. Yes. The first one, base bias or fixed bias. Is base bias or fixed bias. Second one, the circuit diagram. Can anyone tell me why it is called as a base bias? Any clue? Any clue? எதுக்கு பேஸ் பயாஸ்ன்னு சொல்றாங்க? Biasing I know. Biasing I know. Base ஏன் சொல்றாங்க? Any clue? Hello? Okay. If you discuss much, can you see the circuit diagram related to the biasing? Is it visible in
Yes,
both
sir.
the classes?
Yes, sir.
Yes.
Yes,
Yes.
sir.
From this, can anyone tell me why it is called as a base bias? Okay. Let me put a question in a different way. Let me put on a vertical line. Which portion is your biasing portion? Towards left or right? Which one is the biasing portion? Kana biasing is the input or output? Input. Now you can tell me easily, no? Which portion is the biasing portion?
Left side.
Left side. Very good. Very good. So this input voltage to the base terminal voltage is used to bias the IB. The biasing is nothing but, as for transistor is concerned, biasing nothing but creating the base current. Am I correct, sir? As for transistor is concerned, biasing another, I make the IB current to flow in the base current. So என்னோட இன்புட் சோர்ஸ் விசிசிக்கும் பேஸுக்கும் அக்ராஸா இருக்க வோல்டேஜ் எடுத்து பயாஸ் பண்றதுனால இட் இஸ் கால்ட் as a base bias. Is it clear, sir?
Yes, sir.
Is it clear? What is the name of the resistor? RB. What is the meaning for RB?
Base resistor.
Base resistor. Okay, can anyone tell me what is RC then? Collector resistor. Resistor. Very good. Resistor connected in the collector terminal. Resistor connected in the base terminal is called as a base resistor. That's all. Fixed bias that we will attack later. The other name we will attack later. The second one, collector to base bias. Any idea? The same circuit I need to fetch some input from the collector circuit, then I need to bias. In the particular arm, where I am going to remove this terminal, then where I need to keep it in the second biasing? Any clue from your side? Shall I give the terminal names A and B, where you will keep A or B? Since it is named as a collector to base bias, I am asking this. It's collector to base. Where you will keep this lead? In the terminal A or B? Any clue? Terminal? Correct. It's the correct answer. Who told that? Terminal B. Who told that answer? Terminal B? Who told the answer? Yes? Correct தாங்கண்ணா, யார் சொன்னீங்க? Okay, we will see. Collector to base. Is it correct? Perfect. As your friend told, collector to base bias. எங்கிருந்து வருது பாருங்க, இதுக்கு input biasing input. VCC இங்க வருது, collector resistor வழியா pass ஆகி from the collector to base we are going to bias. Therefore it is called as a what biasing, sir? Collector to base bias. Okay. Yes. Is it clear? Any doubt in this diagram?
No, sir.
அவங்க கிளியரா பேர் கொடுத்திருக்காங்க பாரு. We no need to by God. We need to understand. Okay, just understand பண்ணா. Understand பண்ணா cognitive level K1 or K2? Cognitive level K1 or K2? Understand.
K2, sir.
K2, very good. Just like if you bigot, it is just like if
K1,
you
sir.
draw K1, K1, very good. So always you climb the higher cognitive levels. Okay, very good. Third one, voltage divider bias or self bias. Okay, can anyone tell me? Let me draw two circuits in front of you. How these resistors were connected? How these resistors were connected?
Series.
Series. Series. Very good. How these circuits were connected?
Parallel.
Okay.
Parallel.
In which circuit the voltage will get divided across the resistors?
Parallel.
Madam,
Series.
இது முதல்ல எப்படி parallel சொன்னேன்? Please conclude. It's okay. Now you are telling series. Please give a conclusion. How it will get divided in the series circuit? Catch higher cognitive levels. மனப்பாடம் மட்டும் பண்ணக்கூடாது. See, I told you plenty of times. These things were connected in parallel. If you connect the voltmeter across these elements, it will show what? Same voltage. But here, sir, but here it will get series
Divided for
circuit.
each resistor, sir.
It will get divide. It will get divide. Okay. Now, can anyone help me to draw the biasing circuit by the name given in the? Okay, let me put this resistor, or simply I can connect it here. What must I keep it over here to give this name? Voltage divider bias. அப்படின்னா இங்க என்ன இருக்கலாம்? The resistors are connected in series combination or parallel combination?
Series.
Okay, any attempt from your side how you will connect, and which terminal you will give it to base? Any clue from your side, please? Okay, shall I draw two resistors, please? Series. Okay, how you will finish this circuit? Please tell me. Please help me to finish this circuit. I erased everything. Please help me to finish the diagram. This is the two resistors connected in series. How I will bias? Please help me. Shall I name it A, B, and C? Okay. Where I want to connect A? Any clue, sir? Where I want to connect A? Please make an attempt. If it is wrong, also no issue. A, where I need to connect? Voltage divider bias. I need to divide the input voltage, and then I need to give the divided voltage. Yes, A to
VCC.
where? VCC. Okay. Then B to where you will connect B?
Base.
Base. Very good. Where I can connect my other end of the biasing voltage divider circuit? I need to finish the circuit. Am I
Ground,
correct?
sir.
Where I need to connect?
Ground.
Very good. See, if I'm giving 10 volt and the value of the resistors are 5 ohm and 5 ohm, what will be your biasing this voltage? Any clue? What will be the voltage across your base to emitter, sir? Hello? What will be the voltage across base to emitter? I'm giving 10 volt and these two are connected in series with the same resistor
5
value.
volt, sir.
5 volt is the right answer. So please listen. The input voltage is divided and the divider voltage is going to bias my transistor. Therefore, it is named as a what? Named as a what?
Voltage.
Voltage divider bias. It's a very important biasing circuit. Practically, many of the time we will use this. Okay, please note down all the things and also remember the resistor values how they named. This is RC, this is RE, this is RF, this is not RB. Okay, if I put RB, you will get confused with this, the previous circuit. Okay, then in voltage divider circuit, R1, R2. Have you note down this? If you finished, say yes. Please say yes. What is the other name of voltage divider circuit? Voltage divider biasing circuit? Self bias.
Self bias.
Why it is called as a self bias? Why it is called as self bias? It has a separate circuit to bias. Collectorல இருந்து வரத depend பண்ணி இருக்குல்ல. Am I correct? Am I correct? Then in the base to in the voltage depend பண்ணி இல்ல. Self you have a separate circuit to bias. Okay? So it's a self bias. So automatically if you connect like this, it will get bias. Okay. But I don't know what is the name for fixed bias. That we will see later. Okay. Is it these three names are familiar to you? These three names are familiar to you? Have you note down the circuit? Have you know here how to draw the base, where to draw the base current? This is your base current IB. Okay, sir? Yes? Hello?
Yes, sir.
Yes. Yes. Now, so even though we have a three type, we are going to discuss these two types in detail. Okay, because that collector to base bias very rare condition. Applications are too low. Too low na the circuit have little more disadvantage than these circuits. Okay, so we are focusing on only these two. So you also remember the circuit. Okay, understand and draw. Don't by heart and draw the circuits. So fixed or base bias அப்படின்னா fixed RB ல ஒரு resistor connect ஆயிருக்கும் அவ்வளவுதான். So this portion is the common one. You no need to bother about this portion. இதை நீ bother பண்ண வேண்டியது இல்லை. The biasing is the important one. You should remember. Okay. Yes. Then now shall we start our analysis with the fixed biasing circuit? Fixed biasing circuit. The first one, input circuit analysis. Can anyone tell me which portion is the input circuit?
Left side RB.
Can you start trace the input terminals? ஒரு terminal start பண்ணி ஒரு terminal end ஆகிற மாதிரி சொல்ல முடியுமா? The current path or the things
VCC
associated
to
with the
B.
VCC, then
To B.
கொஞ்சம் VCC இருந்து எங்க போகுது? RB, am I correct?
Yes, sir. RB to B.
RB, then see you need to finish the input circuit in this way. இது ஃபுல்லா வந்தாதான் input, higher potential to lower potential, அப்பதானே ஒரு circuit finish ஆகும். Can anyone tell me? VCC
to
then
RB.
RB then
To B.
VBE base emitter then
VBE.
ground.
Ground.
Is it clear, sir? Now the thing is very simple. Very simple. Input circuit analysis abina, it is not a very bigger thing. Read what you need to do. Apply Kirchhoff's voltage law in the input circuit. Please make an attempt to write the KVL equation for your input circuit, please. This is my input circuit. Apply KVL and write. சார் எனக்கு இது கொஞ்சம் டிஃபிகல்ட்டா இருக்கு சார். நீங்க டயகிராம் கொஞ்சம் மாத்தி வரைஞ்சீங்கன்னா எனக்கு ஈஸியா இருக்கும் சார். லெட் மீ டிரா இட். Is it same as the circuit what is available in the right hand side, sir? இந்த போர்ஷனை நான் இங்க எல்லாம் இப்படி கொண்டு வந்து டிரா பண்ணிருக்கேன். புரியுதா? So this is the source or the potential rise. These two are the potential drop. What are all the drop? The voltage across the base resistor and also the voltage between my base to emitter voltage, that is VBE. So when I can write the KVL, if I get on closed path, immediately there will be a current flow in the circuit. By considering the current direction, I can start write the KVL equation. I will tell you one thing to you people. Please listen. Please listen. This is my source. If it delivers some energy to the load, current flow எப்படி இருக்கும்? பிளஸ்ல இருந்து லீவ் ஆகுமா? இல்ல பிளஸ் நோக்கி உள்ள வருமா? If the source delivers some energy, current flow எப்படி இருக்கும்? பாசிட்டிவ்ல இருந்து கரண்ட் என்ன ஆகும்? வெளியே போகும். Am I correct, sir? Am I correct? Am I correct? Okay. Sir. At the end of the class, you will find that the power level in your mobile phone is low. At the time, what you will do? You will put your mobile phone into charge. Recharge. Am I correct? Recharge. Yeah. At the time, can anyone tell me what will be the current flow? Whether
Negative
it will be
positive.
towards the positive plate or away from the positive plate? Towards. Therefore, if it delivers energy, it will be considered as a source. I can put it as a plus. If it receives energy, it will act as a load. At the time, I need to put it as a voltage drop. Can you identify these two difference from your side? Don't get much confused. Please note down this. I will show one example as this circuit. Hereafter, you can write the KVL equation without making any mistake. If you note down these two, please tell us. Thereby, we will start write the KVL equation now. If you can draw or you can take a screenshot. Have you installed that app to take the screenshot without pressing your buttons? Have you found that screenshot app? I forgot to share that app. Today, let me find it, what app I have installed. Okay. Yes, sir. Yes. Shall I continue? Shall I continue? Now. Now. Come to this circuit. Straight away start write the equation. So VCC plus. So VCC plus, this is the source. So I am going to write it as a what? Plus VCC. Now there is a current flow in my circuit due to this VCC source. I can put the source in this side also. So in the VCC, so it is going to deliver some energy to my biasing circuit. So therefore plus VCC. Now the drop across the resistor, voltage drop, whether I need to put minus or plus? Minus. What is the voltage drop across the resistor? How I can find it? IB into RB. Very good. by using Ohm's law, I into R. So IB into RB. Then this is also a drop across my base emitter. Am I correct? So positive current enter ஆகுது. அப்ப அது drop rise drop. Am I correct, sir? So what I need to write here, V B equal to what? Equal to what? 0. The algebraic sum of potential rise and drop equal to 0 I can write, or else the sum of potential rise is equal to the sum of potential drops. In these two ways you can write the KVL equation in the input circuit. Is it clear to everyone, or anyone having the doubt in this? If you are having doubt, please stop me, because further analysis also we are going to do in the same way. And also this is the very basic analysis. From this we are going to do many of the things, differentiation, substitution, many things we are going to do. So if you are not clear in this step, please hold me. Is it clear, students? Please take down the things available in front of you and say yes if you have finished. Yes, sir. Yes. Don't lazy to take the circuit diagrams. If you draw by your own during the preparation time, it will consume very less time. Simply if you take a screenshot, nothing in your hand, and while preparing for the exam or something else, you will be blank. Am I correct? Am I correct, sir? Can I please mute yourself? Somebody is roaming somewhere. We are hearing a horn sounds. Yes, sir. Shall I proceed? யார் ஹார்ன் அடிக்கிறது? Who's that? Anna 108. Correct 108. பிடிச்சம் பார்த்தியா? Okay. Yes. Yes. Now I am going to rearrange the equation. Thereby, I am going to get the base current alone. So IB in terms of VCC and VBE and RB value. Okay, sir? Okay, sir? Hello?
Yes, sir.
Yes.
Yes, sir.
Now, what may be the second analysis? Any guess? Input
Output.
circuit analysis over. What may be the second one?
Output circuit analysis.
Output circuit analysis. And one more term they have added, IC equal to beta times of IB. So that is the known one. So if they substitute that, they will get IC also. Okay. I hope you know from where they derived this one. We know that current gain of the common emitter is equal to collector current to that of base current. So adilandi kandupidichirukanga. They have took this analysis. Okay. Now, output circuit analysis. Can any guess from your side what we need to do and what is the current path and what law we need to apply? Can anyone tell me the path of your output circuit, please? VCC. Quick. VCC.
RC.
RC. Then
VCE.
VCE. Then ground. Okay. Yes. So Now again I am going to apply the KVL in this current path. Tell me the KVL equation for this path. VCC
VCC minus ICRC
ICRC then
minus VCE
equal to
0.
that's all. That's all. If I am rearrange the equation, I will get this. Is it clear to everyone? Please note down. So simple KVL, if you remember, these analyses are nothing. Only the circuits get differ. Okay, but the concept wise, the KVL and Ohm's law won't change. Okay, sir? Yes, I got two analysis. I no need to remember this. If you know the circuit, you can write these analysis. Am I correct, sir? Am I correct? Yes. Yes. Shall I move to the next slide? Shall I move to the next slide?
Yes, sir.
Yes. Now, fixed bias, we are going to see the stability factor. Can anyone recollect and tell me the formula for the stability factor? S is equal to what? 1 plus beta something divided by. Can anyone tell me the formula, please?
1 plus beta
Stability
by
factor.
1 plus
Okay,
beta
you have the formula
divided
in
by
your hand. Okay. Yes, very good. You have the formula. Now we will see the stability factor for this fixed bias. Okay. So fixed bias, now again we are going to apply KVL in our input circuit. So this is our KVL equation. From that we arrived one thing. Now we are going to differentiate the above equation with respect to IC. Okay, you know that the stability factor abinale the small change in current to the collector current to the top your saturation current. Am I correct, sir? This is thing you need to catch to find the stability factor in any circuit. Okay, so the same thing we are going to do it in a step-by-step way. So here we couldn't get it immediately that IC and that saturation current. So slowly we will do the differentiation of this equation and let me attain one thing. Okay, what we attained here, differentiation of with the base current with respect to IC as far this circuit is concerned, it is simply 0. Why it is 0, sir? Right hand side, there is any dependency with your collector current? No, because this, please remember one thing, this VCC is the input voltage what I am going to apply. VBE is, can anyone tell me which one will decide the VBE value? VBE, base to emitter voltage, எதை depend பண்ணி இருக்குது? Can anyone tell me? VBE. Okay, if I give this clue, you can tell இது எதை depend பண்ணி இருக்கு சார்? இப்படி ரெண்டு லைன் டிரா பண்ணாம இது எதை depend பண்ணி இருக்கு? Based on the
voltage.
Based on the material used. Am I correct? Silicon or germanium. Am I correct? In the same way, the base emitter voltages depends on the type of transistor used. In a transistor, you have a plenty of models. The transistor 1, it made the many revolutions. If you watch those videos, you will understand. Am I correct? How many transistors you have it in your mobile phone? Any guess? Roughly? Millions and billions. Am I correct, sir? அவ்வளோ டிரான்சிஸ்டர்ஸ் இருக்கு. ஸோ டிரான்சிஸ்டர் நிறைய டைப் இருக்கு. ஸோ இதுவும் ஃபிக்ஸ்டு ஒன். The supply voltage is also fixed one. Then once you design the circuit, the base resistor value will also be fixed. 1 kilo ohm வச்சுட்டா இது ஃபிக்ஸ்டா 1 kilo ohm தான் இருக்கு. It is not going to vary. Am I correct? Therefore, இந்த collector current க்கும் இந்த parameterக்கும் no dependency, therefore இது base current, if you differentiate with respect to IC, it is 0. Is it clear up to this? Is it clear up to this, sir? Is it clear up to this? Why we are doing this magic? If you see the next slide, you will come to know why we did this step. Okay. Now the continuation of your stability factor derivation. Now we are going to take the thing what we discussed already. Any clue? Any clue what I need to substitute in this equation, sir?
DIB by DIC.
Any clue? Very good. As for this fixed biasing is concerned, in the denominator, this particular term will become 0. Please tell me what is the end result, or what is the stability factor of the fixed biasing? Yes?
1 plus beta.
1 plus beta. Very good. 1 plus beta. Whether the stability factor is a good one or poor?
Good.
Good, poor. What we have studied? The stability factor value should be higher value or lesser value?
Unity, sir.
Unity are in the good. Am I correct?
Yes,
So
sir.
unity, see, listen, this is gain. This is gain. So gain na எப்படி இருக்கும்? We will give something as an input. So output வந்து இது காட்டில அதிகமாக தான் இருக்கணும். அப்ப gain obviously greater than 1 தான் இருக்கும். கரெக்டா சார்? In terms of 100,
Yes, sir.
10 இப்படி இருக்குது. அப்ப stability
Yes,
factor
sir.
roughly if you take the gain as a 10, stability factor எவ்வளவு இருக்கு? 11.
11.
Whether it is a poor or good?
Poor, sir.
Poor, sir.
Poor stability factor. So we concluded that the fixed biasing having the poor stability. So due to the purpose only, the scientist invented the different biasings. So first fixed bias, then collector bias, upper voltage divider bias. At present we are having different biasing circuits. Okay. So stability factor in poor. So they didn't satisfied with this. So they invented something. Okay. Before seeing the different things, please note down this one, please. I hope you people are note downing these things at the back side of your notebook also. Am I correct? இன்னைக்கு ஆஃப்டர்நூன் நீ போய் உட்காருவ, ஒரு டேபிள் போடுவ பேக் சைடில். என்ன டேபிள் போட போற? ஃபிக்ஸ்டு பயாசிங் அண்ட் வோல்டேஜ் டிவைடர் பயாசிங். இதுல நீ கம்பேரிசன் மாதிரி எழுத போற. Am I correct? Is it you people are practicing this? I hope you are practicing this. Okay. Yes. Now, have you note down this content present in this slide? Shall we move to the next slide, please? Shall we move to the next slide, please?
Yes, sir.
Yes. Now what we are going to do, we are going to draw the DC load line in the fixed bias. DC load line varanjamna and the Q point idella kandupidikalam. Correct? So DC load line, how we are going to draw? So DC load line, always we catch the load line equation or your output equation. Correct, sir? Idhula enna magic pananum to get A and B point? Can anyone tell me? A and B are the 2 points. One is saturation point, another one is the cutoff point. Please tell me what we need to do to attain the load points. 2 things we will do. Am I correct? Please refer your previous notes and tell me how we will get the load points. I gave the equation. If you forgot the thing, let me draw the line also. This is my load line. This is my VCE. This is my IC. Please tell how you will get these 2 coordinates.
Sir, keeping IC is equal to 0 and BC is equal to 0. Sir.
Very good. So we need to keep 2 things. First one, VCE equal to 0. So thereby I will get 0, VCC by RC as a 1 coordinate. Am I correct? Second coordinate what? Cutoff point. So there I will put y-axis quantity as a 0. Therefore, VCC comma 0. Am I correct, sir? So this is very much similar to the thing what we have discussed earlier. Okay, please take a screenshot. இது கொஞ்சம் வரைய டைம் எடுக்கும். It will take little time to note down. So this is your Q point. This is your Q point. Now in the voltage, இதை எடுத்தனா this is my Q point. Okay, sir. This is my load line. So load line equations, these coordinates we arrived here. So load line, if I draw in the output characteristics, you will get the Q points. So Q point for the particular base current. In the base current, na consider pandra. For the particular base current, this is the Q point. These and all we have discussed in the previous classes itself. So I'm not going to spend much time over here. If you have note down, please say yes. Thereby we will move. Load line points for the fixed biasing circuit. Yes. Who are writing the content alone will take need time to copy. Others, at least take a screenshot, please. Yes. Now, shall I move?
Yes.
Yes. Now, why the biasing is called fixed bias? Can anyone tell me? They have fixed bias. Any guess from your side? Why it is called as a fixed bias? Already, zero on after we discussed something. Okay. If you apply KVL in this circuit, this is the equation you will get. From this equation, VCC, VBE and RB, all the values are a fixed one. Am I correct, sir? Am I correct, sir? Due to this parameters, my base current is also a fixed one. It is not going to vary. So because இது வந்து collector current depend பண்ணி, see these parameters not related to the load what I am going to connect. So let me tell you one thing. Here you will find two things. No, one is the base. Any clue what is this RC from your side? இது என்னவா இருக்கலாம் sir? It is not a simply resistor. This is your load. This load may be your buzzer, your LED, or your relay coil, anything. Okay. So இதை நம்ம actuate பண்ண போறோம். So whenever you bias it, this particular load will get turned on. Is it clear, sir? Is it clear? So இந்த load இங்க vary ஆகுது. But if you vary the load, nothing will impact in my bias circuit. The bias circuit, it is not going to disturb. The base current is going to be a fixed one. Due to the purpose only, this biasing is also called as a fixed bias. Purida, sir? Purida. If a temperature vary ஆச்சுனா, collector current vary ஆகும். But it won't disturb your base current. It's remain fixed. Okay? Is it clear? Is it clear?
Yes, sir.
Please take down. Please take down. This may be asked as a 2-mark question or a 3-mark question. You should not write all the things what we have discussed so far. Only these 4 lines are sufficient along with the circuit. So if you write, if you know what you have to write, see, we are finding many things are have copied from your handout. And okay, and let me finish all the answer sheet and give that overall view of your answer script. I didn't completed your 100% answer script correct. After that, I will give you the whole thing what we have observed. Okay. Is it clear up to this, sir? Why it is called as a fixed biasing? Why it is called as a fixed biasing? Yes. The next one, the thing related to this is, if I vary these things, the base current never changes. So it is called as a fixed bias. And also one more thing, if IC varies, Q point also varies. So this change in Q point will make the stability to poor. Okay. Therefore, we are not going to encourage this fixed biasing circuit. We are going to the new circuit is called what? Voltage divider bias. Okay. Temperature vary agumbodhu the gain vary agudhu. This gain will affect your collector current. This collector current will in turn will affect the Q point. Kana idu or best example rakana. Yaro ortha answer eludra, you are posting it to someone, avan paadi eludran adha thukki innorthanta kudukuran. Ipo last eludran romba affect avam, correct ah? Avanukku filter ஆகி answer போய் reach ஆகும், correct ah? Don't do the practice while you are writing the exam. Everyone write it by your own. If you write it by your own, affect வந்து பாத்தீங்கன்னா ஒண்ணே தான் இருக்கும். Maybe temperatureனா உன்னோட memory, உனக்கு என்ன அண்டர்ஸ்டாண்ட் ஆயிருக்கு அதை நீ எழுத போற, கரெக்டா? If it varies, your output will vary. இதோட ஸ்டாப் பண்ணிக்கோ. If you circulate, நிறைய பேர் பாதிக்கப்படுறாங்க, கரெக்டா? Don't circulate your answers to your friends. Thereby, if it is a perfect, they will get 100 out of 100, but they won't get succeed in their life. Am I correct? So don't circulate your answers while you writing examination. It's my humble request. Okay. Yes. So a fixed bias la one more, the thing is, you know that from the previous derivation itself, it is one, the stability factor is the 1 plus beta. Also the temperature varianaala unoda stability disturb ஆகுன்றது இந்த parameters வச்சு explain பண்றாங்க. Therefore we are going we are in a limited way we are going to use this biasing, but mainly we are going to use this voltage divider bias. So if I spell voltage divider bias, உனக்கு அந்த என்ன circuit ஞாபகம் வருது சார்? What is in your mind now? What is in your mind? Inputல என்ன இருக்கணும் சார்? Inputல என்ன இருக்கணும்? Two series resistor. இது உனக்கு மைண்ட்ல இருக்கணும். But இதுக்கு immediate you can't write a KVL equation. So KVL equation எழுதணும்னா என்னோட input and output consider பண்ணினா, see, I'm not getting a single current path. After this it is getting divided. Am I correct, sir? Divide ஆகுதா? So ஒரு single loop க்கு தான் we can write the KVL. So for that purpose, we are going to do one small thing. We are going to get the assist from the scientist name called Thevenin. இது நீ படிச்சிருக்க மாட்ட. So we are going to get the help of the scientist Thevenin help கேட்க போறோம். The Thevenin will give you one hint that how to convert the little complex circuits into a simple circuit. அவர் என்ன பண்ணுவார்னா, he will give one analysis and he will give the end result as only two component, ஒரு source ஒரு resistor மட்டும் தான் கொடுப்பார். ஓகேவா? So the whole input circuit he is going to convert it into something, and he is going to give with the two elements. One is the voltage source, another one is the resistor. Okay. Let me explain this thing in a very simple way to you people, not much analysis. I hope you can view my paint screen. Am I correct, sir? Can you see this circuit in front of you? Circuit mattu theriyudha, sir?
Yes, sir.
Yes, sir.
I am going to make it very simple to you people, not much analysis. Before this, let me draw one circuit to you people. இப்படியெல்லாம் ஏதாவது ஒரு சர்க்யூட் இருக்குன்னு வச்சுக்கோ. ஓகே, Thevenin என்ன நமக்கு ஹெல்ப் பண்ண போறாரு அப்படின்னா, I have these many components in my hand, but in these two terminals, if I'm going to connect any load, ஏதோ ஒரு load connect பண்றேன், LED, speaker, relay, or any system I am going to connect it. So connect பண்ணா அப்படின்னா, this is my load. This is what I'm going to consider as a load resistor. But my input circuit is a fixed one. Am I correct, sir? இது ஃபிக்ஸ்டா தான் இருக்கு. எது மட்டும் வேரி ஆகுது? Only the load resistor. அப்பதான் அந்த தெவெனின் என்ன ஃபைண்ட் பண்ணாருன்னா, why I need to carry these many elements in my circuit during analysis? Why can't I convert these many elements into only a simple elements? Simply ஒரே ஒரு 2 elements வச்சு அனலைஸ் பண்ணக்கூடாது அப்படின்னு அவர் திங்க் பண்ணாரு. திங்க் பண்ணி என்ன பண்ணாருன்னா, he introduced one circuit. That circuit consists of a one voltage source and one series resistor. இவ்வளவுதான். The whole circuit what you had it previously, now he converted into the equivalent circuit consists of a one source and one resistor. அப்ப அதுக்கு என்ன நேம் வச்சாங்க? What they named? அவரோட நேமே வச்சிட்டாரு. இந்த சோர்ஸ்க்கு என்ன பேர் வைக்கிறாரு? VTH. அப்படின்னா அது என்னன்னு சொல்லலாம்? இந்த சோர்ஸ்க்கு என்ன பேர் ஹியர் ஆஃப்டர்? தெவெனின் வோல்டேஜ். இந்த ரெசிஸ்டருக்கு என்ன பேர் வைக்கலாம் சார்? ரெசிஸ்டருக்கு என்ன பேர் வச்சிருப்பாரு? எனி க்ளூ? RTH. அப்ப நம்ம இது எப்படி கூப்பிடலாம்? தெவெனின் ரெசிஸ்டன்ஸ். Is it clear to my students? புரியுதா? அவர் என்ன பண்ண போறாரு? If you give any linear complex circuit அவர் கையில கொடுத்த அப்படின்னா, he will convert it into a simple two elements, voltage and source. Voltage and one resistor connected in series மாத்திடுவார். The same technique we are going to adopt it here. Okay. How he will do this equivalency means, simply what I am going to do, we are going to consider our input circuit alone. Our input circuit alone அப்படின்னா, அவுட்புட் சர்க்யூட் என்னவா சார் இருக்குது? அவுட்புட் சர்க்யூட் வந்து ஒரு ஓப்பன் சர்க்யூட்டா இருக்குன்னு நினைச்சிட்டேன்னா, you will have only these element in your hand. I didn't given any bias current. If IB is 0, this circuit will be open circuit. So open circuit na, இந்த சர்க்யூட்ல என்ன ஒரு கரண்ட்டுமே ஃப்ளோ ஆகாது, கரெக்டா? So I can skip this portion and let me have this circuit. இதான் இப்ப நம்ம கையில இருக்குது சார். Is it clear, sir? Are we having only these elements in our hand right now? Is it clear, sir? Now I am going to find what is the equivalency across this terminal. இந்த ரெண்டு terminal A, B, because these two terminal only going to bias my circuit. Is it clear, sir? So இந்த ரெண்டு சர்க்யூட்டுக்கு அக்ராஸா என்ன இருக்குன்னு கண்டுபிடிக்கிறது தான் தெவெனினோட ஒர்க். ஓகேவா? So தெவெனினோட ஒர்க்ல you need one voltage and one resistance value. This voltage we are going to name it as a Thevenin voltage. This we are going to name as a Thevenin resistance. Okay. I will tell you one thing. The Thevenin voltage is very simple. If I connect one voltmeter across this, what is the voltage is getting appear in this open terminal? In the open terminal across enna voltage varudho, that is your Thevenin voltage. So this is my VCC. This is my VCC. This is resistor R1. This is R2. Can anyone tell me what is the voltage across these two terminals? Is it this voltage drop across these two terminals is equal to the voltage drop across this R2? இந்த R2 across என்ன voltage இருக்கோ அந்த voltage தானே your VTH. Am I correct, sir?
Yes, sir.
Now you can tell by yourself. What is VTH? What is VTH? Any clue, sir? Any clue? What is VTH? What is VTH? Voltage drop across this resistor VR2. What is the voltage drop across VR2? This is current through the circuit. This is the current through the circuit. இது வழியா ஒரு கரண்ட் ஃப்ளோ ஆகுது. இங்க ஒரு டிராப் இருக்கும், இங்க ஒரு டிராப் இருக்கும். கரெக்டா சார்? கரெக்டா சார்?
Yes, sir.
எஸ். What is the current first of all? What is the current first of all? I ன்னு என்னது?
IB,
I
sir.
equal to VCC divided by what? R1 plus R2.
R1.
Yes. Now I got the current value. So VR2 is equal to I into R2. Shall I substitute this I over here in the first equation? What you will get, dear students? Can anyone tell me? VCC divided by R1 plus R2 into
VR2.
R2.
Is it clear, sir? Now simply we are going to name that as VTH. VTH. VTH kadichicha parunga. Are you got the VTH now, sir? Are you got the VTH now, sir? VCC into R2 divided by R1 plus R2. Kandipidichacha? Is it clear? We got the Thevenin voltage. It is new to us, but it is very simple to find. Kandipidichitama? Please say yes or no. Or we got the VTH, sir?
Yes, sir.
And the source எடுத்து drop on it. Now my intention is to find RTH. Can anyone tell me, somewhere you have studied this formula in your school days? R1 into R2 divided by R1 plus R2. R1 into R2 divided by R1 plus R2. You have by got it somewhere. How many resistors are in parallel will yield this equation? Two resistors. That is the clue. That is the clue here to us. How we are going to attain the RTH value in this circuit. So Thevenin gave one more concept, how to find the RTH. So earlier I have connected voltmeter across this terminal. Now can anyone tell me what meter I need to connect across these two terminals? How to measure the resistance? What is the meter for that? Have you studied that with the symbol of this? See, earlier I have connected this. You pronounced it as a voltmeter. Now I have marked this. How you will pronounce this meter, sir?
Ohm meter.
Ohm meter. Very good. Ohm meter. So ohm meter will yield the resistance value. So now I have connected ohm meter. But the thing is that whenever I am connecting the ohm meter, I should not give any input supply to my circuit. I need to zero down or nullify the effect of the source. So voltage source or equivalent, very simple. I am having the source. 10 volt. இந்த 10 volt எப்படி நான் 0 வோல்ட்டா மாத்துறது? இது ரெண்டையும் இப்ப நான் ஒரு வயரை வச்சு ஷார்ட் பண்றேன். Are you find any potential difference between these two?
No, sir. Zero.
It will become 0. Am I correct? So simply I am going to remove the source and I am going to make it as a short circuit. Now this is R1, now this is R2. How these two resistors were connected? Whether these two resistors are connected in series or parallel? Series ன்னு சொல்ல தோணுது உனக்கு, கரெக்டா? Series அப்படின்னா எப்படி இருக்கணும் சார்? R1 series with R2 இப்படி இருக்கணும். இப்போ in betweenல இப்படி ஒரு பாயிண்ட் வந்துருச்சு பாரு, இங்க ஒன்னு எடுத்துட்டாங்க. And also the other end of the R1 and R2 are connected together. If you are having two common points between two elements, that is said to be what connection, sir? Series or parallel?
Parallel, sir.
I redraw the circuit. If I redraw the circuit, you people will get more clarity. Now I am going to do one thing. Now I am going to remove the R1 what is present over in the upper side. Now I am going to keep it here and I am going to draw it. இங்கிருந்து R1 அப்படியே தூக்கி கொண்டு இங்க வச்சிட்டேன். Now you tell me how these two things are connected. Parallel. Now can anyone tell me what is the value I will measure in this ohm meter? RTH is equal to R1 into R2. Am I correct, sir? Am I correct, sir? It's very, very simple to find the Thevenin equivalent circuit, but you no need to do much exercise. Do remember how we got this. இது எப்படி கண்டுபிடிச்சோன்றத மட்டும் உனக்கு ஞாபகத்துல இருந்தா போதும். Okay, you no need to do much analysis with the Thevenin and Norton. It's a very big concept. You need to solve many sums, then only you can understand this concept. Now this is the equivalent of this circuit diagram. Is it clear to everyone how we arrived this equivalency? Hereafter we are going to do the analysis only with this circuit. Thereby you can write the KVL equation in your input circuit and output circuit very easily. Am I correct, sir? Am I correct, sir? Yes. Please take down the circuit. Don't bother about these many values. Keep it as a simply RTH and keep this as a single source VTH. Is it clear, sir? Is it clear? Take down. Let me give a minute of time to take down this. Then we will analysis the input circuit analysis and output circuit analysis. Then we will find the stability factor and we will compare with the fixed biasing. Then we will conclude that which one we will use it most. Okay. Yes. Shall we move from here? We have a 10 more minutes in our hand. Shall we continue the discussion, please? Sir, tired ஆயிடுச்சு சார். பரவாயில்ல. இதுக்கு அப்புறம் கொஞ்சம் ஸ்கிரீன்ஷாட் மட்டும் எடுத்துக்கோ எழுத முடியாட்டி. Shall I move from here?
Yes, sir.
Yes. இது இப்போ எப்படி வந்துச்சுன்றதுல பெரிய காம்ப்ளெக்சிட்டி இருக்கா? It's not much complex. Am I correct? Yes. Now, so voltage divider biasing எடுத்தாச்சு. So only these elements keep in your mind. My humble request, you forget this one. Only RTH மட்டும் மைண்ட்ல வச்சுக்கோ. இங்க என்ன நாம வச்சுக்கணும்? VTH மட்டும் வச்சுக்கணும். போதும். These equations and all you forget. RTH and VTH. இத மட்டும் மனசுல வச்சுக்கலாமா? Yes. And also இது base to emitter voltage மாதிரி இருக்கிறதுனால it is simply called as a VB. இது அத காட்டிலும் சிம்பிளா இருக்குது. கரெக்ட்டா சார்? Am I correct? Yes. With this, please tell me what is the input circuit analysis using KVL? Can you tell me the equation, please? First trace the path. எங்கிருந்து எங்க வரணும்? Input path. Where to where? Hello?
VTH to RTH.
Okay. VTH, RTH, then
RE.
RE. Very good. Let me see. This is the path. This is the closed path. Am I correct? Okay. Now you tell me the KVL equation for this.
VTH minus RTH minus RE equal to 0.
Die. How we separate RTH? This is the voltage equation. Yes. Voltage equation அப்படினா இந்த இதுக்கு across இருக்க voltage I need to find. So RTH into what?
IB, sir.
IB. Don't make those mistakes in your. Is it clear, sir? Is it clear?
Yes, sir.
Is it clear? You forgot VBE. Am I correct? You forgot this VBE. So since here they didn't mark, you didn't take it into account. Let me mark it here as a VBE. So what are the components associated in this KVL path? VTH, voltage drop across the resistor, the drop across the base to emitter, then drop across my emitter. Now we are going to replace this emitter current into something. Emitter current we are going to replace it with something. What is that? IE is there. What? Emitter current is equal to. இது என்ன law? இது என்ன law apply பண்ணி எழுதுறோம்? KVL or KCL?
KCL.
KCL. So we know that emitter current is the summation of my base current and the collector current. நான் இங்க பாரு KCL எப்படி அப்ளை ஆகுது பாரு. Consider this as a single node. ஒரு சின்ன டாட். நம்ம அன்னைக்கு ஸ்கூல்ல படிச்ச டாட். இந்த டாட்ல பேஸ் என்டர் ஆகுது. கலெக்டர் என்டர் ஆகுது. So obviously இது ரெண்டும் சேர்ந்து இங்க டெலிவர் ஆகுது. So I is what? The sum of these things. Am I correct? This is the leaving output. These two are entering input. So இது ரெண்டு எடுத்து எழுதணும்னா this is the equation. So if you substitute, your equation will become like this. Am I correct, sir? Am I correct? Am I correct?
Yes, sir.
Yes. If I further substitute blah blah things, I will get this. Our intention is to get the base current. Then we will differentiate with the collector current. Am I correct? Then we will substitute that equation into your stability factor equation. Correct? This kondu poy last stability factor la we need to substitute. If you substitute, we will get some stability factor value. At end result is the important. This is the approximate value of the stability factor. Can anyone tell me from this end result, the stability factor is a good or bad?
Good.
Good, sir.
Comparative with what? Comparative to what?
Fixed bias or
Fixed bias. So it's a good stability. Okay. So let me give these things as a homework to you people. Please do this. No meaning to spend much time over here. These are all simple calculations. Yes. Can I please take a screenshot of these slides and do it by yourself and try to get the stability factor approximately equal to 1. Okay. Yes. So shall I move to the second slide, please?
Yes, sir.
Yes. பசி நேரத்துல உன்னை நான் பழி வாங்க கூடாது. ஓகேவா? Take the screenshot of this. ரெண்டு ஸ்லைடு ஸ்கிரீன்ஷாட் எடுத்திருக்கியா?
Yes, sir.
Yes, sir.
Third slide to find stability factor. So in previous class also what we have did, we found IB and IC. In the differentiation value we will find it in some way. Okay, ஏதோ ஒரு magic பண்ணி we will get this value. Why? We need to substitute this in this equation. Okay, have you take a screenshot of this one? Have you took the screenshot of this one? Yes, sir.
Yes, sir.
Yes. If you substitute that value here, you will get this as the equation. Take a screenshot. Simple max. At least you do it in the rough note and get the answer, please. Okay, ma'am? Yes. Shall I move to the next slide, please?
Yes, sir.
Yes. The lengthier derivation practice பண்ணேன். Okay, ma'am? Since it's a descriptive type, they may ask this derivation also. Am I correct, sir?
Yes, sir.
Do practice. And the next slide. Yes. At last, only one assumption We arrived this one. We arrived this one. Let me expect answer from you people. This value, if it is very small, அதுக்கு ஈக்குவலண்டா நம்ம என்ன கொண்டு போய் இங்க சப்ஸ்டிட்யூட் பண்ணனும்?
0.
Mathematically 0. Very good. Extremely small அப்படினா 0. Simply tell, if I make 0, this term will get cancelled. This will also will get cancelled. What will be in your numerator part, please? 1
So 1 plus IB by 1 plus IB, sir.
If I cancel these two, what I will get?
1, sir.
1.
Why it is approximately 1? Any guess?
So because there is a small value in not
That will be
against
a
the
small value. If you substitute here, you won't get exactly 1, approximately 1. Okay? Yes. So by this, we are going to conclude that the stability factor of the voltage divider biasing is good. Okay. So with this, we are going to shall we stop here? Yes, we will stop here. What we will see tomorrow, we will see, we are going to draw the DC load line. Okay, then we are going to find the Q point. Then we will do some analysis in this. Then immediately we will go to some numerical things. To solve these things, what you must have it in your hand, please. என்ன இருக்கணும் உங்க கையில நாளைக்கு இதெல்லாம் சால்வ் பண்ணனும்னா? என்ன இருக்கணும்? Please have a calculator. We will solve 1 or 2 sums in the tomorrow's class. With this, half of the transistor, that is our module 2, will get end. Module 2 la or half the portion we will finish. நாளைக்கு வெறும் sum தான். Okay va? Let me plan it for 20 minutes to finish. Okay va? I need your cooperation to solve those things. Have a calculator in your hand. Do it by your own. Exam